Hello everyone, I'm Greg Weaver. Welcome to The Audio Analyst. Those of you who follow my Facebook posts will be aware that the suite of WestminsterLab electronics, their Quest line stage and a pair of the Ray monoblocks, designed and manufactured in Hong Kong, landed here for evaluation in early September of last year. After spending several weeks with them, and following a brief follow-up conversation about their arrival I had with Gary Leeds, the founder and managing partner of Hear This, WestminsterLab's U.S. importer, it occurred to him that no one had ever reviewed these products as they were originally designed and intended. Their creator, Angus Leung, had originally built and intended for the Ray amplifiers to be used as a bridged monoblock pair per channel. And while I did not make a specific request to do so, Gary graciously volunteered to send me a second set of Rays and a master-built reference 2 series bridging cabling kit to make such an evaluation a reality. They arrived in mid-October. While I was duly impressed with what I heard with that implementation, using 4 Rays in bridged mono configuration, and their ability to deliver a notable advance in performance over the use of a single pair, that full review is upcoming and will appear both in print and as a companion episode here at the channel. Today, I'm honored to bring you a discussion with WestminsterLab founder and principal designer Angus Leung. If you follow the channel, you may recall meeting Angus back in April of 2024 with episode 119, when he took time out of his hectic show schedule at Expona that year to share a conversation with me. That episode is linked in today's description section for those who may have missed it. But I was recently honored to have Angus accept my invitation to make time to have a Zoom conversation with me so we could discuss some of the technologies, engineering, and innovations that go into both the Quest line stage and the Ray monoblock amplifiers. Here he is. Welcome, everybody. As indicated, we've got my buddy Angus Leung here. He's speaking to us from Hong Kong. It's early morning in his time zone, and it's early evening here in the Midwest, and he's been gracious enough to join us and talk a little bit about the WestminsterLab products that I've recently got to spend a good bit of time with, the Quest line stage and the Ray amplifiers. Can you walk us through what inspired these products? Because I know for a fact that oftentimes the inspiration from what forces you to think about and build something to when it becomes a manufactured and marketable product there can be some time in between. And you launched the company in 2012? Is that correct?
12, yes.
Okay,
that's correct.
So walk us through that, Angus.
Well, it begins from it was like 20 something years ago, actually.
Okay.
So when I was still a kid, I used to work in an audio repair shop, if you know.
Guilty.
So if everyone remembered in previous interviews. So the inspiration of manufacturing audio products or not manufacturing, just making stuff.
Sure.
Is like in my heart. I used to like playing with Legos and building blocks and etc. etc. So I like to make things by hand, and I used to do a lot of small projects for my friend. If a friend of mine would like to have a headphone amplifier, back in the days we were playing with headphones, and I would just build him something, and then he would give me some feedback, and then we would just kind of research and development a little bit. I love this stuff.
Sure.
So the idea of becoming a company is where I thought it was when I was in university in London, actually. So it was like a couple of years before 2012, actually. And then we thought maybe we can, if our products are that good, if people are loving it, maybe we can just put it on the market and see what will happen. Back in that era, I was studying architecture in London, so I would say, okay, yeah, let's build a website and start marketing it. But in the beginning, we were a cable manufacturer, so we
Okay.
went to lots of distributors. We have lots of interesting talk, but not a lot of people saw us seriously. People would just say, "Oh, another cable company," not another cable company. That's all.
Yeah.
And then we have decided that way maybe we can put some electronics to production, because when we were developing the cables, we were testing them on our own electronics, you
Sure.
know. So, and people seems to like it, as a combo. So we think maybe we should just do that, and then and that's the cause of it. I would say there's a reason why we go into the electronics. And it worked so far. So we're really grateful that it worked. But in terms of the inspiration of like why the product is, kind of look like that or sound like that, you know, I think it relates to a little bit to my background. As an architect, I like things to be engineered or designed properly, and
Sure.
and I always believe that these equipment should be part of the living room. So they are furnitures in a sense. So I designed them as with a minimalistic design in heart.
Well, I will say
To
the industrial design is very distinctive, very clean, very pure. Some people may not like it as much as others, but that's how the aesthetics go. I
Yeah,
found them to be extremely sexy. They're beautifully built. They're well built. But the appearance alone, I think, is going to attract some users. So didn't mean to interrupt, but I do think they look pretty good.
thank you. Yeah, and this kind of philosophy also extends to the reproduction of sound as well. We want to have the least fingerprints that left into the music notes when we try to handle them. Everything is built upon this kind of idea, minimize, optimize, and we would like our customers to just enjoy music
Sure.
rather than thinking of the equipments.
That's the goal. Well, it should be the goal. I know, I think so. But all right, so the Quest line stage is a beautiful, slim device. It's got an interesting perforated light up kind of front that shows the
Yeah,
input choice, the volume at the time. It has exclusively XLR inputs and outputs. There's three inputs, two outputs, which is great if you want to run a separate set of subs, or if you want to run two lines to four amplifiers, whatever. Um, but there's also two expansion bays on the back for growth. So you could add a single ended input if you chose to. And you have two different phono stages right now, right? There's a normal moving magnet, moving coil stage and an optical phono stage for things like the DS audio stuff.
yeah.
Um, Now, was that always a plan from the beginning to have those kind of optional bays, or was that something that you realized when you started building it, hey, we should make sure that it does this?
Well, the optional bay in it was there at the right at the beginning.
Okay.
So we were thinking additional XLR inputs or RC inputs,
Okay.
because the Quest is like fully balanced. So we really need additional circuitry to convert a single-ended signal to a balanced input for its operation. The phono stage came a little bit later, to be honest. So when we work with Gary say, okay, your stuff is great, but we really need the phono stage. And then in the beginning, we were kind of like, are you sure? Because we've never touched any vinyl stuff. No, a couple of years ago.
I won't hold that against you, buddy.
We were in the digital age. Everything is on digital. So and then we did a little bit of study. We bought some turntables, a couple of records, and then we think, well, maybe we can do one. from in the expansion bay. So luckily, we have built in all the criteria that's needed.
Right.
So separate left and right power supplies, inputs and outputs, etc., etc. And then, yeah, the module is kind of like our first product into the phono world. And of course we keep it open, what will be coming,
Sure.
in the
Yeah.
future. We don't know.
Well, they're called expansion base for a reason. You can expand into the
Yes.
comes up. So
Yeah.
now the volume control is a 64 step resistor. It's pretty
Ladder.
precise. Is it 1 dB increments?
It's around 1 dB.
That makes sense that it would be.
Yeah.
The thing that I found really fascinating was the little switch underneath on the front between
Mm.
for the hybrid grounding. There's a,
Mhm.
a less aggressive and a more aggressive mode. Can you discuss those briefly?
Well, it's basically how we combined the signal ground to the chassis ground. At which
Ah,
point? At which point? So the more aggressive grounding, we ground it in the earlier stage of the signal to the chassis. So it in some kind of a system, it may make it, a little bit more darker.
okay.
But we found out that when we ground it at the later stage, there may be a little bit more musical
Yeah.
and nuance sometimes. So we can't make a final decision on which mode to go for. So at the end of the day, maybe it's not a major difference. I wouldn't say it's like night and day,
No, but it's
but
audible. It is audible.
yeah,
It
it's
is audible.
heardable. Yeah, so we think maybe for the customers, to tweak the system a little bit. It may be an interesting because we left no options, for customers to tune the sound, because
Sure.
our approach is like very minimalistic.
Yeah.
So
Yeah.
we want to make the decision for our customers, but this is the one thing that we left for our customers, to tweak the system a little bit.
Now, another thing that's important to note, I think most companies try to do this, but you do spend a lot of time on compartmentalization, the isolation and the shielding of different sections so that you don't have RF dispersing into other things and there's nothing radiating into more sensitive components like that. Um, I got to tell you, I'll try and put up some images of the inside because it's a beautiful looking chassis. It really is. Now, the Ray amplifiers, that we're going to get into some of the technology in a minute, which is really important to me. And you and I discussed this back. When did I talk to you? After Axpona. It was let's see, it was 3 Axponas ago, 2 years ago. Um, and we spent. You were kind enough to let me do an interview there, and we talked about it. And I'll have that linked in today's description area so people can see that because we talked about it there too. But if you can go through, I mean, the thing that fascinated me when I was talking with Gary is the first pair came in September, and we talked, and he said, I realize I've never had anybody do a review of the bridged pair, and he said, honestly, that's how Angus designed them as that pair. So he was I didn't ask. He was kind enough to send me the second set and the bridging kit, the master built bridging kit. And I got to tell you, buddy, the in my system, the difference was remarkable. I really felt the difference, and it wasn't just the increased power, which would explain some of the scaling and ease that was going on, but there was a difference in nuance and in resolution and in microdynamic things that was surprising. But what I would like to get into is this iBias thing, this sliding bias thing that you use.
Mm-hmm.
Because you call this a Class A amplifier, though it weighs what, uh, 20 pounds? Can you walk us? I'm not asking for, proprietary secrets, but can you talk about how this approach works and how, I mean, it has to be somewhat reactive, but there's also a secondary constant current source option that you use, and we'll get into that in a minute. But can you
Mm-hmm.
talk about how this bias works?
The sliding bias thing is not new, to be honest. Crow has done it, decades ago. Other Gryphon also we use it as well. So we just implement it because we want the package. That the iBias thing exists only because of the compact package.
Sure.
And also we can generate a little bit more headroom
Okay.
for the power supply, because we don't have to have more oversized power supply than we needed. So it is reactive, as you said. So that's why it works. The bias works on the temperature.
Okay.
It's temperature and coherent controlled. So, for example, if you're listening to some casual violin solos, let's say, and then all of a sudden you switch to heavy metal and you turn up the volume, it will run into AB.
I would never.
Yeah.
Yeah.
So, but for example, if you were half way through the heavy metal, the sounds, it will gradually grows up in bias. It feels the warmth, it feels the current, then it adjusts the bias a little bit more. So I would say 95% of the real listening sessions, it is in Class A. It's a very good Class A B as well, but most of the time it's Class A.
Sure.
Yeah.
The thing that I found really fascinating. So, and typically when you bridge amplifiers, you get about quadruple the power. Truly, I mean, are we talking like you go from 100 watts to at 8 ohms to 400 watts, and at 2 ohms, is it truly quadrupled, or is it like, I mean,
you can't.
Yeah, okay, thank you. It's probably what, maybe 2.5, 3 times as much. Well, I'm glad that, because a lot of people claim straight across the board doubling or quadrupling the power, and and believe me, my 4 ohm speakers with 700 watts or so with the bridge pair, which is what my other amplifiers put out, it's pretty impressive. The scaling, because especially with certain arena rock and particularly full scale orchestral music, that scaling makes all the difference in the world in believability. So it really made a difference. Now, also when you bridge amplifiers, you're basically giving each amplifier one phase of the signal. And then you bridge across typically the positive outputs. Now, what's nice about the rays is they're preset, so you don't have to think about it. You don't have to be smart. I mean, you don't have to go out and go, what do I do to bridge? I got 2 identical amplifiers. There's a way to, you have XLR throughputs and markings on the back to make it easy for people to bridge these. And I think that's remarkable. And I think that people who like one should hear the bridged pair, because to me, in my system, granted, my speakers are pretty massive. They're not hard to drive necessarily, but they're $250,000 a pair. And what they do, their ability to reveal microdynamics and to reveal timbre and tone and texture is excellent. And the pair seem to really, and I'm not knocking the single unit. I mean, they're excellent, but the pair really, the improvement was incredible. Is it in part because doubled input impedance, or is it, I mean, is that part of it? I don't know.
Well, this will be a bit longer in terms of an answer. Right. So technically speaking, you're right. If we double the impedance, the damping factor will be half. So technically speaking, that will be a disadvantage. But scientifically, human cannot hear any difference if the damping factor is around 100 and 200. So this is all we need. Technically speaking, that is just from research papers, of course. So we have 1,000 damping factor on a single unit. So even if we bridge it, if it goes half, so that's 500. That is way above listening level in terms of what science.
This is all psychoacoustic effects.
Yes, exactly. So normally for other amplifiers out there, when you bridge it, there are consequences.
Sure.
In terms of sound. So most of the time you hear a bit more distortion. Things seems a little bit rougher. You hear less details. And that is because they are not matched. So what's the secret in terms of, well, it's not secret anyway. when we manufacture a pair of rays in terms of the same serial number,
I forgot to
we
talk about
match.
transistor matching.
Yeah, the transistors resistors are matched at every single stage.
Yeah.
So the buffer, the amplifying stages, the current stages, every stage has been matched.
Yeah.
So these two units are working in perfect harmony in order to amplify it. What I would say is the bridging actually gives us more voltage in terms of headrooms.
Sure. Yeah.
Because in terms of the circuitry of the rays, right after this first stage of the buffer, where we need the buffer to isolate between the preamp and the power amp. So right after the buffer, there's no ground within the circuitry.
Okay.
So there's no ground. So it's just positive rail to negative rail. There's no ground.
Okay.
So when we bridge it, the positive of the positive phase, let's say the positive transistor of the positive phase of the amplifier is actually working against the negative transistor of the negative phase of the amplifier. So we get double the voltage difference.
Sure.
And we think that's the magic. And also you got common mode rejection CMRR because you basically two units are actually rejecting the noise together.
Right. Yeah.
So basically you get, technically speaking, you get 6 dB or 3 dB more in terms of background darkness. So that's what we think in terms of how we can put what we observed as the difference scientifically.
Yeah.
But it's more than power, we think, because we had one client using a Wilson Banish resolution. So it's a big bookshelf speakers, but it's still a bookshelf speakers. With the bridge pairs, it's got tears in his eyes in 10 seconds. So it's much more than just 4 times the power.
Oh yeah,
it's a complete different animal.
Well, and that's what I was trying to suggest is the difference that I heard here was not commensurate with what I normally hear with bridged amplifiers in that sense. The transparency, the resolution, the nuances, especially when I'm listening to like fingering on violins or cello. I mean, not so much with arena rock, but with really delicately recorded material, pianos. Oh my God, you can hear hammers hitting strings. It's a remarkable setup, and I was really taken with it, and I really was glad you were willing to sit down and talk to us about it because I think the bridged pair is remarkably better than the single amplifier, which is a good amplifier. I'm not knocking the single units. You understand that. But in my room, it was just a good amplifier. The pair were brilliant. Yeah. The pair were brilliant.
Yeah. You mentioned about the current source.
Yes. Oh, yes.
Earlier one.
Yes. Yes.
So that was that is used in the earlier parts of the amplifier. So in order to boost the distortion, and because we didn't use cast coke, so in terms of technical stuff, so we didn't use cast coke in our circuitry. So that's why we need the current source, constant current source in our first part in order to make it to get more lower distortion figures and high currents in that stage. So it's very A. It's running very class A in the very early stage of the amplifier.
I'm gonna look at my notes again too. I didn't talk about the minimalist signal paths. I didn't talk about the resonance control. I didn't talk about the asymmetry and the shape. Dude, the look of the thing, the carbon fiber top, the heat sinks on the side. I love the hidden switch underneath the faceplate. The physical approach is not only obviously well designed, it's, I think, very aesthetically pleasing too. We touched briefly on the extreme transistor matching and the other tolerance of the parts across all the data points. But that minimalist signal path, do you want to talk about that? There's only how many parts in the signal path?
Well, if you combine the quest and the rays, there's only 21.
Wow.
So 21 active and passive components, we're saying.
Sure.
So the signal only go through 21 resistor and transistors.
Wow.
That's it.
Okay.
So, well, we tried our
path.
best in order to minimize. Yes.
It's a short path, yeah.
Because we think the least that we can have in there, the least problem that we have,
Sure.
because it's very difficult to match a lot of resistors. So by making it more easier to approach to what we try to match all the transistors and resistors to, that the easiest approach is to reduce them for a good reason, because
yeah.
less is more.
In the case of audio, yes, I completely agree.
Yes.
Yeah.
Yeah.
I really can't thank you enough for taking time out of your Saturday morning to
No, not at all.
It's really cool. I really appreciate it. And listen, next time I see you, the first drink's on me. We had a great dinner at Expona 3 years ago. We had so much fun.
We did. Yeah.
And that video of our conversation from Expona will be posted in today's description as well. Buddy, stay safe in Hong Kong. I'm sure you're not shoveling snow like I've been dealing with the snow here.
No, not at all. It's like summer here now.
I'm sure. Angus, thank you so much, pal.
Thank you so much, and it's good to see you again in your audience as well.
Always good to chat, buddy. Stay safe, and we'll talk again soon. Okay.
Take care.
All right, man. Bye-bye.
Bye-bye.
My sincerest thanks to Angus for making time to share his insights on these products with us. I can't wait to catch up with him in person at this year's Expona in April. Further, links to all relevant sites and full pricing details are available in today's description section. The days following this episode will find me traveling to Aalborg, Denmark, where I've been invited to cover Audio Group Denmark's gala flagship product launch, the Symphony of Innovation, to be held at the House of Music, Aalborg's beautiful 1,300-seat cultural center and concert hall. The following weeks will have me scurrying to Tampa for the Florida International Audio Expo, and then on to Orlando as well to pay a visit to fellow journalist and friend Maurice Jeffrey's new apartment lounge. And as if that weren't enough travel, the first week in March will find me in Quebec, Canada, covering a special event at the Boutique Audio Gallery, a luxury audio dealer in Montreal. Given the amount of travel, the time zone changes, and the extensive number of epic events I'll be covering over the next several weeks, the regular drop times for new weekly episodes may be impacted. But rest assured, I'll be bringing you boatloads of exciting new content, so be sure you are subscribed and have notifications enabled so that you won't miss any of it. As always, thank you for taking the time to drop by today. Further information on supporting the channel and my efforts may be found in today's description section or at my companion website, theaudioanalyst.com. Please stay safe and keep the music playing. Till next time, cheers.